Why is the NFTs palette considered one of the most advanced NFT solutions, not only in Polkadot, but like in the wider ecosystem? That's what I want to talk about today. Like, I'm a big fan of the NFTs palette. I happen to have the opportunity to work closely with the core engineer that actually like architected the palette, Yegor. And I would like to share with you like why I think this palette is so freaking amazing. So I have this Polkadot SDK cloned down on my machine. And inside that, we have the substrate framework. Inside the substrate framework, we have frame, right, where all this frame folders where all the palettes, the frame palettes live, and you'll find the NFTs palette right there, right? So before I dive into the code, like I just want to give you a little bit of the history behind it, right? So prior to this NFTs palette, there already existed NFT work in Polkadot, in the Polkadot ecosystem. And it was considered NFTs 1.0. It's called Uniques Palette. So those of you, this might be new to some of you, but yeah, we had NFTs already in Polkadot with the Uniques Palette, and some blockchains are still using Uniques Palette till this day. Um, it was a while back. I think maybe like 3 years ago when this palette was like first introduced. I can't remember the exact timeline, but more than 2 years ago. And uh, this has some basic NFT functionality. And around that time, like there was a lot of like innovation happening around NFTs. If you think about like, I don't know, like soulbound NFTs, just like different creative ways to use NFTs, right? And the Polkadot community that was using the Uniques palette, they were asking for more. They wanted more features. There were some things that were missing in this palette. There were some things that they wanted that would be nice to haves. And they kind of voiced it to the community, aka at the time Parity. And Parity listened and they brainstormed this new palette with it's called NFTs palette, and it's considered like NFTs 2.0, right? NFTs 2.0 features, and it's got a ton of features. That's why it's so advanced. One of the main reasons is because it's super configurable, right? So let's take a look at it. Right away, I'll tell you, I love this palette because of the way that it's like configured here. Like it takes a very modular approach at organizing the code, which I really like. So let's start with the librs. With the librs, I want to highlight to you. Let's jump straight into the config. So if we scroll down, here's the palette config. And right here, this is where I want to start. So the author of this palette, Yegor, he was the main author, right? The guy who kind of like designed this. Uh, he decided to create a concept of origins, which this is a theme throughout like substrate palettes. You know, it's common for you to have special origins. But this is something that you want to think about when you're configuring the palette for your blockchain, right? That there are these special origins, force origin and create origin, and how do you want to implement them? So, for example, force origin, you can think of as an origin that has elevated privileges in this palette, right? So, uh, do you want to give elevated privileges to a specific account? Do you want to give elevated privileges to a DAO, like a collective, right? An on-chain collective. This is what you want to think about. Similar with create origin, right? Can anybody create use create? So like if you look at create origin where it's used in the create dispatchable, right there, create origin, right? So if you look at the description here, issue a new collection of NFT items from a public origin, right? But if you actually look at the code, well, here it says this new collection has items initially, and its owner is the origin. Okay, but let's look at the code where create origin is. So owner, we're actually doing here create origin, ensure origin, and we're passing in origin and collection, right? So origin here is coming from what's passed in here, right? So we're making sure that that origin ensures to create origin. That's very interesting because if we look at our config, right, where that's where in our config with create origin, if we scroll up, we have to define, we have to, when we're configuring our configuration, we have to, define what create origin is, right? So can anybody create collections in our blockchain? Or do they have to be a specific account or specific origin, right? So that's interesting, right? That's something that you configure and that you're going to have to think about when you're configuring this palette into your blockchain, right? Because maybe you have a use case where you only want collectives, a certain collective to be able to create new collections. That's fine. Or maybe it's open to the public, right? So origins are there. Um, so let's scroll down. I want to show you, like, for example, if we go back to that create, the create dispatchable, it's the very first dispatchable. Here it is, create, right? So this is to create a new collection. And when we want to create a collection, it's very simple. You know, you have the caller, the origin, you set the admin for the collection. Admin will have certain privileges. And then you have the config for the collection. Okay, so whenever you create a collection, there's a concept of a configuration for the collection. So let's actually look at that, what that's about. If you open up the substrate folder in the NFTs palette and you go to types.rs, this is probably types.rs is probably like the most important file in this palette. Like it's so amazing, so rich, full of types and data structures that are used throughout the palette. So there's collection config 4, right? And you can see it's defined here. So this section of the top file, it's like at the top. When you look at it at first, this could be overwhelming, especially to those of you who are new to like Substrate Rust. But in reality, this code here was actually written to simplify things, believe it or not. So like you can see a lot of these types, they're saying like deposit balance of, right? Collection details for, and then for, and then, of, right? So these are all type aliases for what follows after it. So like, for example, this chunk of Rust code here, right? Would you, every time you want to use, this code, would you rather type all this out? Or would you rather use a type alias, right? So that's why the author created these type aliases, so you don't have to write these like ridiculously long pieces of code, right? So for example, this one here, right? This is pretty advanced Rust code. Maybe I'll do a video another day to explain how it works. For today, all you have to know that these are just type aliases that represent that code, okay? So the one that we're looking at is collection config 4, and it consists of collection config right here. And if we actually look at the configuration for the collection where that's defined, which is in this file, here it is, collections configuration. It's a struct, right? And it's using so a configuration for a collection consists of the collection settings, the max supply of the collection, which is optional. You could have a collection of like 5 NFT items. You could limit it, U32, or you could have it not specify a maximum supply, so it could grow. And then the collection configuration also consists of default settings each item will get during the mint, which is type mint setting. So let's look at the collection settings. What is a collection setting? Well, we can look that up. Collection settings is a struct right there, struct collection settings, and it consists of collection setting, which is defined right above it. You can see it's an enum and collection setting. These are the collection settings: transferable items, unlocked metadata, unlocked attributes, and so on, right? So when you're configuring a collection, you set the collection setting. So do you want the collection to be able to have items that are transferable, yes or no, right? Think about like, what's beautiful about this is like, this is just code, like this is technical, but in like the whatever, I don't even know, I'm not really involved in the NFT like nomenclature. But like I've heard like soul-bound NFTs, right? Maybe this is an example where if you disable this, no, you can't transfer. You mint an NFT item, whoever it belongs to, that's it. It's theirs. They can't ever transfer it, aka soul-bound NFTs, right? So unlocked metadata. The metadata of this collection can be modified. So if you want to modify the metadata or not, This is creative, right, in terms of use cases. Unlocked attributes. So attributes in this collection can be modified, similar, right? Unlock supply, similar. Okay, cool. So that's collection settings. And you can see, you might wonder, like, why is it this bit flags thing here going on? And like, if you see here, wrapper type for bit flags collection setting, and up here, it uses the bit flag. So it's a library. I believe it's like inside the cargo.toml somewhere up here, right there. So yeah, it's a dependency. Okay. So this was a very creative and novel way that the author is using bit flags for efficiency, right? Because at the end of the day, we're storing all this in blockchain storage. Blockchain storage is expensive. So using bit flags is a very creative way of keeping everything efficient, especially in terms of settings and configuration, right? So that's why we see that here. So let's go back. That was the collection config when we create a collection. Okay. So this is the dispatchable function for it. And we can see the very first line of code in the function is uh, creating the collection. So it calls next collection ID and it grabs it. So if this is the very first collection, it will call collection ID initial value. Okay. So in order to understand this line of code here, we actually have to understand what the heck is a collection ID. So let's go back to our config. Um, and this is very, very interesting here because it's actually an important piece of this whole palette, like the collection ID and what it is. And it's defined in the config. It's the very first thing in the config. If you scroll to the top of the config, well, it's the second thing. First thing is the runtime event, which almost every single palette uses runtime event because, like, yeah, you could design a palette that doesn't emit events, but most palettes emit events. Um, so here it is, collection ID, identifier for the collection of item, type collection ID. It has to adhere to these traits. The most important one that we want to discuss today is incrementable, right? So collection ID, whatever we choose, however way we choose to implement this, it has to adhere to the incrementable trait, which makes sense, right? We should have our collection IDs for our collections. They should be incrementable, right? So that's important to note because when we go to create a new collection and it's the very first collection, it'll call initial value. So if we look up initial value, I'm going to do a search here. So let's do search. Okay, all right. Search. So if we look here, I'm inside of frame support, right? Look at that. Public trait incrementable. Okay, that's cool. All right, cool. Our collection ID is adhering to this, and it has two functions. One is increment, nice, and the other one is initial value. Oh, look at that. Haha. So if we look at the search, there was another entry here in frame support. It's the actual implementation of initial value, right? It looks like it's some macro or something. And we can see that initial value is set to 0. Okay, so hopefully now that makes sense. If we go back to our create collection, we understand that that's what's going to happen there. It's going to be the very first collection ID, right? The first. So that's there. So we're creating the collection ID, creating the collection. We're ensuring that the owner, has the privileges to create, right? Otherwise, you can't create. And then admin. So, we pass in the admin here, who's going to be the admin of the collection. We pass it in some account ID. So then finally, we call do create collection. So the way that this palette was designed and architected was that there's a folder inside the palette called features. And all these features, you can say these are palette NFT features. These are features around this NFT, like everything that you could do with NFTs in this palette, right? And some of them can be enabled or disabled, right? And all these, each one of these files, you can think of them as like different features that are called from our dispatchables. Like in this one, it's called do create collection. So for example, in the create delete collection RS in the feature here, we open that up and we scroll to the top and we say do underscore create. There it is, do create collection, right? So uh, these are functions that are used in our dispatchables depending on if the features is enabled or disabled, right? So do create collection is the function for creating the collection, and you can see that it's grabbing the deposit from the account, it's inserting the collection, a new collection, and it's setting the roles, and you can see there's the collection, there's the admin, um, and then it's going here and depositing the event. So looks like the event, where is that coming from? To create collection, we're passing in an event. So let's actually go back. Let's scroll back to the do create collection. Interesting how this was created. We're passing in an event created. Event created. Okay, so there's the event that we're passing in. Okay. And then for config, you can see the config is coming from here. So we pass that in as well, right? And just to reiterate, if we look at config, this is the config, right? Collection setting and mint setting. So collection setting, collection setting is setting enable collection setting. Okay, here it is. So this is all getting passed in, right? When we're setting up the collection, and we create the collection based on that. The other thing that we pass in as part of the config is the mint setting. So mint setting struct, and mint setting struct consists of several mint type, price, start block, end block, and default item settings. So I like to the way that sometimes I like to drop in like into the UI. So actually, the NFTs palette is live in production on Polkadot via the Asset Hub, right? So what you see on the screen is Asset Hub. It's producing blocks, and if we go into the extrinsics and we actually look for the NFTs palette, it's there. So I could use dot to like literally mint a collection right now, and we're looking at the create, right? So let's go to create. And you can see that that's like it's a different way of looking at it. Instead of looking at the code, you can see collection config for, right? And then you have the settings. And here the UI isn't very helpful. This is a U64. It's supposed to be the bit flag representation of it. So whatever we pass here. So really to get this, we would have to use like a third-party tool or something to get the appropriate bit flag that we want according to the settings. And then the other ones, max supply. So if we look there, um, it was back in the collection config. So if we look collection config, max supply, right? So max supply settings, settings. So why is that U64? I'll show you. Collection settings struct because of the bit flags, right? And we see up here collection setting representation U64. Right? So we got to figure out the appropriate bit flag for that using like a third-party tool. I heard there was somebody in the ecosystem creating a UI specifically for this palette to make it easy to just like check this on, check it enabled or disabled, and then at the end it'll actually like create the collection for you. But I don't have that handy right now, so you would have to use a tool to like convert it here. And then mint settings. So the mint setting can be these three different types, right? So let's actually look at that. So mint settings, that's where we were. So that's part of the collection config, right? And I believe that was the default mint setting that we're specifying there. And we say mint type. And mint type is defined right here, enum mint type. And there's these three different mint types, right? So who can mint items? Who can mint NFTs in our collection? Well, maybe only issuers can. So they have to have a special role, which we have defined in here in this file. I'll show you in a bit, called issuer. and only issuers are allowed to mint NFT items for that collection, right? Or maybe anybody can mint an NFT item. Hey guys, I just created a collection. First one, there's only 20 of them. First one to mint gets it, right? Public, mint type public. And then the cool creative one is holder of. So holder of would be, hey, if you hold an NFT item in this collection that we created previously, like then you can mint in this collection here that I'm creating, the new one that I'm creating, right? And you need to prove that, right? So there's logic around that in this palette to kind of prove that if you use holder of. So you can think of like the use cases, like actually, I mean, I can't really think of like I can think of one use case, right? Like, hey, like VIP type of stuff, right? If you uh, owned an item that we minted, an item from a collection that we created like 5 years ago, right? We're going to have some event this year where we're going to create a new collection and mint the item, and it's only for those people that were around in the community 5 years ago, right? Some special status NFT items. I don't know, like there's a lot of use cases that could spawn just off of this line of code here. So what else? Mint settings, mint type, an optional price. So an optional price per mint. So like each item will be whatever, 5 dot, right? It's optional. You could have nothing and therefore it'd be free mints. And then starting block, when does the minting start? When can I start minting? When can these people start minting? And when does minting stop? Right? And then default settings, each item will get during the mint. So item settings. So let's see. What are item settings? So specifically for item, so item setting, item can be transferable. So a specific item, if this is enabled, you can transfer it. If it's disabled, then you can't transfer it. Item, right? Before we were talking about collection level metadata. Now we're talking about item level metadata. Can metadata be modified or is it locked? Right? So you think usually metadata, like what's metadata versus attributes, right? Metadata is usually like typical NFT scenario. It's like that's the JPEG that you upload to IPFS, right? Whereas attributes, these are key value pairs that go along with that NFT item that are it's part of the NFT, but you can think of them like as key value, right? So this is where like there's so much creativity behind this, right? Because like one would say, well, isn't it dangerous to like have the metadata unlocked? Like if they have the privileges, they could just swipe the JPEG for another one, right? It depends on your use case, right? What if these were upgradable NFTs, right? And you have like these key value attributes, and depending on how these key value attributes evolve and change over time, the JPEG morphs, right? It evolves, like some AI type of stuff, right? Who knows? Like there's so much creativity right here. Okay. So that's item settings, and that all spawns, right? When you're creating a collection. So if we go back to collection config, that all spawns from here, right? And keep in mind, these are the default right here, the mint settings, okay? So that's there. So if we go back to, we were looking at do create collection, and this is the logic for creating the collection, right? And you can see that in the create collection, at the end of the day, after it calls the do create collection right there, and it creates the collection, it'll also emit an event. Then it'll call set next collection ID, right? So we remember the very first one, it's going to call initial value, right? 0. And then finally, after it's created the collection, it'll say, hey, let's increment it. Let's bump it up, right? Set collection, set next collection ID is defined. It's kind of like a helper function. So Yegor, the architect behind this, uh, he decided to create a file called common functions, helper functions. And in there, if we do a search for set next collection ID, there it is. And I want to point this out because it actually, if we look at the Liberas back here, we're passing in the collection that we just created. And in set next collection ID, okay, we're grabbing it and we're saying collection dot increment. So if we remember, I think I have it here still. if we look at the implementation, right, or if we look at the trait, incrementable, there's an increment, right? An increment will, the implementation, it will increment according to this logic here, okay? So saturating include, so we get back that incremented value. So if we go back, let's see, actually I want to go back to my helper function. Yeah, set next collection ID. We call increment, which gives us the next ID. We then store it in storage, calling set with next ID, and boom, we incremented the collection ID and fire off an event. Pretty cool, right? So that's how you create a collection with the code. And this is, I would say, like once you've created a collection, a common next step is to set a team around a collection. So like there's different roles that uh, can work with a collection. And you kind of saw that when we're looking at the do create collection right here, collection roles. Um, so after you've created a collection, like you can set a team. So like, for example, there's this dispatchable called, I believe it's called set underscore team. Yeah. So set team to dispatchable, right? So it says here, change the issuer, admin, and freezer of a collection. Origin must be either forced origin or signed, and the sender should be the owner of the collection. By setting the role to none, only the forced origin will be able to change it after to some account. Okay. So this is to set the team for a collection, and we pass in the collection ID that we want to set the team for, and we specify the account for the issuer. So this will be the one that can issue, and the admin has certain privileges. Freezer, right? Freezer can freeze, lock, the collection, and it has other privileges as well. So that's simply what we're doing with this dispatchable. We're calling do set team. So if we look here, do set team would be inside, it's inside features, right? It's one of the features. It may be inside of roles. Let's take a look at that. Yeah, it's inside of roles. So do set team. Set the team roles for specific collection. Okay, so this is the logic of setting the team. And we can see that this is where we're taking in the accounts, issuer, admin, freezer, and we're giving them these roles, which if we look, it's defined in our types.rs, which almost everything is defined in there. Collection role, issuer. Okay, so an issuer is the one that can mint items in that collection. Interesting. Okay, freezer can freeze items, and admin has the ability to can thaw items, force transfers, and burn items from any account. Okay, so you really want to think about that when you're creating a collection. One account could be all of these, or you could have separate accounts. It's up to you. All right, so that's creating a collection. The other thing that I want to show you in this folder here, there's something called implement non-fungibles. If we open that up, this palette, NFTs palette, it's actually implementing, we can see here, inside of frame support, traits, tokens, we're implementing non-fungibles v2 trait, the traits in non-fungibles v2. So what is that? So if we go, that's inside of the Polkadot SDK. I'm going to open up the Polkadot SDK Rust docs, and I will show you. So we're going to look at non-fungibles v2, this one right here. And non-fungibles v2, it has traits for dealing with multiple collections of non-fungible items. And you can see these are the different traits: create, destroy, inspect, and so on, trading and transfer, right? So for example, if we look at inspect, public trait inspect, it has its own required methods that one needs to implement: owner, collection owner, attribute, custom attribute. So if we go back to the code and we scroll down, you can see here implement, inspect, and owner. And here's the code, the custom code that the author created to implement owner. right? It's just grabbing the owner from the storage. So attribute, right? So there's the custom code for attribute, and so on, right? So this is the implementation of those traits. More interesting one, I would say, is this is destroy. Here's mutate, and I think trading is in here. Yeah, trading. So implement trading. So if we look at trading, go back one here, trading, trade for trading on NFTs. So it has buy item trait. Sorry, it has the trading trait has buy item function, set price, and item price. And if we look here, buy item, we call do buy item. Set price, we call do set price, and so on. Item price, right? So we're adhering to these traits, just so you know, it's important. They're used throughout the code, and this is where we actually implement the trait. So that's why this file exists. Um, if we go back to types.rs, actually, if we go back to the librs and the config, I want to show you one more thing. If we scroll to the config, right after the origins are defined, and right after the limits, yeah, like right here, type features, get palette features. It says disable some of palette features. This is a bit like misleading in my opinion, this comment, because like it's really like where you're setting the palette features. So there's certain palette features. Like, let me give you an example of this, of implementing this config. So a great place to look for example implementations of configs, palette configs, is inside of the substrate kitchen sink node. So if we go inside of the substrate folder, bin folder, node folder, runtime, source, librs, the runtime's librs. And I'm not gonna, this file is huge. I'm gonna say implement palette underscore NFTs. Yeah, so pretty much almost, I don't know, I think it's every single palette is implemented here. I'm not sure if it's every single one, but let's say like most of them. I never did a check if there's all of them, but you can see this file is like huge. Um, here's palette NFTs, right? So this is the one that we're looking at. You can see this is interesting. Force origin, they're setting it to ensure root, which that's fine for a kitchen sink node, but like, if you have a blockchain, a company, a blockchain, you probably have some type of governance. You probably don't want ensure root. You probably evolved past the pseudo palette. So let's see. The other one, oh, where's create origin? Create origin. Do you see create origin? Create origin. There's create origin. Okay, so they have that as ensure signed account ID. Okay. And then the one that I'm talking about now is features. Features is set to features, and that's defined up here. Public features of type palette features, and palette features all enabled. So you can see that's really where we're setting the palette features. And in this case, they're saying like everything. You can do all the palette features. So what the heck are palette features? Let's look at that. So it's actually not inside, it's inside of our types. Everything is inside of types. So palette features, there it is. It's a struct. It uses the bit flags, consists of palette feature, which is right above. And these are palette level features, NFT palette level features. So these trickle down through the palette, depending on what we set here. Right now, the kitchen sink has all of these enabled. So that means trading is enabled, uh, setting attributes is enabled, um, and working with approvals. So approvals, like in terms of this palette, like there's certain functionality in here that allows you to delegate certain actions to other accounts. Like, for example, you could approve another account to do the transfer of an item that you own on your behalf, things like that. So that can be enabled or disabled. Swaps, think about like swapping NFTs, atomic swaps. Like, hey, I have this NFT and I want to make a statement on chain saying that like I'll swap this NFT, my one that I own, for this other NFT that's in another collection or the same collection or whatever. And then there's like, the logic around that. So do you want to allow for swaps on your chain or not, right? So another like thing that you have like you got to think a lot because like these are pallet level, right? So that means when you're configuring your blockchain with this pallet, you need to know which ones you're going to start with as enabled or disabled. Not even start with like this will probably be like once you have this enabled or disabled, it's like it's probably you probably want to set this in stone, right? So requires a lot of thought on like what kind of like NFT solution your blockchain is like offering, right? So that's palette features. So if we go back to um, types.rs, which is where we are at, there is one more thing that I wanted to show you here that I thought was pretty cool. So see, yeah, this one here, attribute namespace. So attribute namespace, this is in accordance with attributes. So collections can have attributes, right? If you enable it on the, or disable it. Items can have attributes, right? These are key value pairs for your NFT item or for your collection, right? So remember that I said that there's metadata and there's attributes. So I gave you an example of like what the difference is, right? Um, Attribute namespace, that means that it's kind of like who will be setting the attribute. Is this a palette level attribute? Is this a collection owner attribute? Is this an item owner attribute, right? And this is an example of like how configurable and how feature rich this palette is. And then the last one, an attribute was set by a pre-approved account. So you could pre-approve an account to set an attribute. That's kind of crazy, right? Like the use cases that could come out of that, right? Um, I would love for somebody to like comment on like example use cases for this one. It's I think that there's a lot that could come out of this one. But even like the trading or like the palette features, right? If we go back uh, here, right? Like say you're creating a use case where there could be trading of NFTs, right? A platform for trading NFTs, right? So this could be handy. Um, or say you're creating a use case where there's buying and selling of NFTs, trading, but it's done through an intermediary, right? So that's why you need approvals. Or there's so many combinations that you can put together in terms of the configurations that you can come up with. It's pretty amazing. So let's go back to attribute namespace. So I want to show you actually like some of you may think like when would a palette level attribute be useful, right? So let's actually look at like where this palette level attribute is being used, if anywhere. So let me see here. Files to include. Can we do NFTs? Not root. Okay, so that's too many. I believe that inside of our lib, if we go to mint, so our mint dispatchable, where we mint an NFT item, we call do mint. And just to show you do mint, right? Where would that be? That it's inside, it's a feature. It's like you can mint. So features, create and delete item. I believe it's here. So do mint. Yep, it's there. This is an interesting function. You can see, we pass in the collection item, who it's meaning to, item config, and then we have this with details and config, right? So this here, uh, this is what you see when we go back to the dispatchable. You see the do mint, blah, 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 right here, right? That's the logic here. So it's going to execute this. And if we look at this when we're minting, it does a number of checks, and then finally, like it goes here and it calls mint settings dot mint type, and if the mint type is of type issuer, right, then it does a check. Is the caller like, are they an issuer are they of the type issuer? Otherwise, don't give them permission to mint. And then finally, there's a type holder of, right? And we saw that. So they got to be a holder of an item of a specific collection ID that they pass in here. And when you call this, um, we have access to a mint witness. So mint witness, I think it's here. Yeah. So when you call mint, actually, we can look at the extrinsic on the UI. It might be nicer to look at. See, mint. So mint. So it's optional, the mint witness. And you can see, oh, that's nice. It's actually, yeah, it is nice to see the own item, right? So, hey, if you do, own an item from a specific collection or whatever, then you need to prove it here, owned item. So if we look here, witness data, and we scroll down, and collection ID, where is that coming from? Collection ID. Oh, that we're specifying here as a parameter. Okay. So we specify, they're going to provide the mint witness as part of the mint data, and it's going to include the owned item. And what we do is we check that that account actually does own the item that they provided in the mint witness data, owns item. And if they do, then this check will pass. Otherwise, it'll say, hey, bad witness. Like, yeah, you don't own that item. And remember that if we go to types, right, only holders of items in a specified collection could mint new items, whatever we specify there, right? So that's why we're doing the check that they're providing mint witness data. So that's also, this type is also here. Witness data for items mint transactions. Provide the ID of the item in a required collection. Item ID. So here we're providing the item of a particular collection. What I find interesting though is that here we don't specify a collection, we just specify the item. So how do we know which collection we're specifying it? The only way that I could see it is that if it takes on whatever we specify here. So from my understanding, whatever collection we specify here, it's assuming that this belongs to this. Let's just confirm that. So collection details. Collection ID. Collection ID item. So if we prove holder of mint type holder, mint settings, mint type. Owned item. Contains key caller collection. Yeah, it looks like it would take on that collection. So if it's true that they do actually own that item from that collection, then this passes, and we'll proceed to the next section here, where we're creating a pallet level attribute. So pallet attributes used to claim. So the reason that we look at the types RS, really move this closer. So if we look at types.rs and we say, where did it go? Pallet attributes used to claim. So these are the only two palette level attributes that exist nowadays, right? Like in the future, there might be more, but right now there's only use to claim and transfer disabled. So use to claim is a palette level attribute, and that's what we have here, use to claim. And we're setting it to palette attributes, and then we're creating a key. The key is taking in the collection ID of, you know, where the collection that the item belongs to, the one that they proved with the witness data, and the actual item that they own, which was proved already. And then we're creating a new attribute, and this is a palette level attribute, so the namespace will be palette. So it's just showing you like when is this applicable, right? Because this attribute is not being created through an extrinsic, right? I'm not firing off an extrinsic and signing a transaction saying, hey, I want to create this new key value attribute, right? This is actually being created on the blockchain level through code right here on the palette, right? That's why it makes sense to be a palette level attribute, right? So we're creating the key here. So here's the key. And then we're making sure that this key doesn't already exist in the attribute storage, meaning like that they haven't already claimed it, right? And if so, then proceed. And right here, we actually insert this new attribute. So we can see here key, and then the actual, the attribute there. So we're inserting this into the attribute, and we're firing off an event, telling the world that, this collection ID, um, that the user actually owns that item, and it's a palette level attribute. So that's the event there, right? So this code is really useful in terms of, you know, uh, claiming, making sure that they actually own an item from the collection ID, in order that they can they can mint this new item, which, by the way, all this code that we've been looking at, once that fires off and executes, then finally we fire off the do mint, because we can see the do mint here. We can see that it's the code that we just went over is this right here, right? So it's going to fire this off right here. Okay. So once that fires off, then it's going to proceed to actually minting the NFT item for that account. And you can see here it's minting. There's the account, and we're inserting the new item into the account storage. Okay. And finally, we down here, where is it? We do item insert collection, item details. Yeah. Believe there should be an event fired off somewhere around here. Might be in the Libras. Witness deposit event. Yeah, just went over that one. And then do mint. There will be an event for the actual minting. I believe it's defined in another function. Let's see here. So item owner mint to item. Section. Okay. Hmm, where was this? Oh, it's right here. Sorry. Deposit event issued. So item issued, and the collection and the item and who it was minted to. So that's the event. Okay, cool. So that's minting. And that was an example of a palette attribute in action. So uh, interesting, right? The other one is transfer disabled. So marks an item as being restricted from transferring, but it's a palette level attribute, right? So where would this be useful? This is actually, I believe, inside of implement non-fungibles, and it's inside of so if we look at the code here, the trait, we go back, transfer. We're implementing this. So you can see required methods for this trait, transfer, disable transfer, provided methods. So disable transfer and enable transfer. So let's look at that. I believe transfer. Let's say disabled. What was it? Disable? Okay, so here's transfer, the traits, and transfer, disable transfer. Transfer disabled. Look at that. It's checking has system attribute for that item, uh, palette attributes transfer disabled, right? And then it says if transfer disabled, emit an error. And then here, we're actually setting the attribute. And this is where it makes sense for it to be a palette level attribute because we got blockchain level code that's creating an attribute, right? Therefore, palette attribute, right? And which one? Well, transfer disabled. So that's where you see transfer disabled used. So hopefully it's making a little bit of sense, like the difference between a palette level attribute and what's the other one? These other ones here, right? When would you use one versus the other? So this is more for like, if I were to create new palette attributes, I'd have to like, modify this palette, do a PR or something, do a runtime upgrade and such, which is fine. Like depending, like if you have some better, you think of some features that you want to include here. Whereas these, you can create attributes just using extrinsics, the dispatchables and such, right? So these you can look at, like, for example, attributes inside the features folder. And you have doSet attribute. So doSet attribute is called inside of the librs. I believe it's called set attribute. So it's a dispatchable called set attribute, set an attribute for a collection or item, right? And it looks like it accepts a namespace. Let's check that out. Attribute namespace. DoSet attribute. So you pass in the namespace there. Okay, so let's look. DoSet attribute. The namespace in which the attribute is being set. It can either be collection owner, item owner, or account. Notice you can't use palette here, right? And we know why, because that's like on the actual blockchain level code. Wouldn't make sense to be used here, right? So we have collection owner. So maybe we want to set an attribute on a collection level. We have item owner. Maybe we want to set an attribute for an item. And then we have account, which is a pre-approved external address. Okay, so that's set attribute. So that's another cool one. So in here, you're going to find other features. You can kind of like, it all goes through the same pattern. Also, one recommendation that I have, that if you ever get stuck on like, how do you call a certain dispatchable in the NFTs palette, go to the test.rs. Test.rs has like a bunch of like use cases written in code of like, hey, this is how you create a collection, this is how you set a team, this is how you emit an item, this is how you use the witness data and such, right? Actually, to that note, like witness data, one thing that got me a little bit in the beginning was like, we have the, what is it? Create, well, something witness, create, destroy witness. Yeah. So we have destroy witness, but we have the other one that we covered. We covered mint witness, right? That we want to prove something. What about destroy witness? So we can see here, there's one called destroy witness is a struct. And it says the total number of items in this collection that have outstanding item metadata, the total number of outstanding item configs of the collection, and so on, right? Like, why do we need this, right? This was something that was kind of like, it's not logically in the code, it doesn't explain. If we do a search of like where it's used. So let's see here. So you can see in the test, here's an example. Should not work, this one. For collection metadata. So let's see. I want to see actually like here. Okay, yeah, let's take a look at this one. Destroy the specified collection with given collection witness and maybe check owner. This function destroys the specified collection if it exists and meets the necessary conditions. It checks the provided witness against the actual collection details and removes the collection along with its associated metadata attributes and configurations. Okay, so when we destroy a collection, we have to pass in um, the witness. So like if we look at the Polkadot.js, I believe there's a extrinsic called destroy. Yep. And you can see here's the witness data, right? So we got to pass all these in. We actually saw this in the code, and it has to match. So you can see there's it's matching, right? It's checking, making sure that they match. Okay. So that's where the witness data is. Uh, but it doesn't really explain like why we need to do that check, right? Curious about that. Like, why do we need to specify that? Is it that, maybe it's this destroy a collection would be too powerful because, we don't know exactly, the blockchain will change its state and maybe what we wanted to destroy like at one moment is like different at another moment. And that's why we provide the witness data. Maybe that's why. I'm not sure. It'd be nice if the code kind of explained that a little bit, the why. So that's the other one that I want to point out, the witness data. And there is like buy, sell. It's just like there's some interesting stuff here. So do pay tips. So there is a dispatchable called is it pay tips? Allow to pay the tips. So this is more of like a voluntary thing. So you could, it's like no one was ever able to like solve like royalties permissionlessly for NFTs. There have been attempts, but um, it's really hard uh, to do that to actually do royalties for NFTs and make it work because people could go off chain and there's ways that you can circumvent it. So the best that the ecosystem figured out were like voluntary payments or tips, right? So that functionality is there if you want to tip. So that's it. I think there's more like little things scattered throughout here. You can read up on the different features that exist here, locking and unlocking and such. But with this, you have the potential, like with all these configurations, hopefully it highlighted like that. There are many, many, many use cases, and I've only seen like a very small percentage of this palette being used in production. Usually it's just like traditional, like, create a collection, mint NFTs. Um, but so much more can be created out of this, like marketplaces that are very powerful for trading, um, and creative technical solutions as well that I would like to see. The other one that I wanted to show you, I think, is create, delete. There was one more, metadata, roles, transfer. There was one more thing that I wanted to show you. Buying, setting the price, updating the mint settings. Oh, the other one was the off-chain stuff, which I think is a bit unique. So if you see, there's a dispatchable called mint pre-signed, right? So it says mint an item by providing the pre-signed approval. So it says mint data. So we provide the mint data. The pre-signed approval that consists of the information about the item. So for example, if I go into the UI here and I say mint pre-signed, right? And it's expecting the mint data and the attributes, like the whole, like mint data, right? Like to collect the item that we want to mint with its attributes and everything, right? And it's also expecting the signature. So the signature of the data object. So what this can do is we could mint an item off chain, sign it, and then one could call this extrinsic to actually like mint it, right? So maybe I'll cover that in another day. I wrote a tutorial about it. It's on a HackMD online. You can search for it, how to do it. But that functionality is there. Um, Curious to see like what use cases could spawn out of that. And there's also set attributes pre-signed. Okay. So that was the other last feature that I want to show you that exists there. All right. So that's it. Hopefully I've covered the most important points in this palette. Um, there's more. So please study the palette and would love to get your feedback as well. And hear some creative ideas of like technical stuff that can be created from this palette, or even how to extend this palette and make it even better, right? So thank you all.